Hey guys, this video is for educational purposes only. Please do not break the law.
So let me ask you this. How are beneficial microbes interacting with this crop steering? Do you find yourself recommending different microbes at different phases? Are they affected by these drybacks or mostly unaffected, or some more than others?
I think the science is still widely not fully understood on how what we're doing is really impacting the life cycle of the microbes, because the flower cycle is so short for the life cycle of reproductive cycle of things like mycorrhiza and fungi. Bacteria reproduce a little bit more quickly and adapt more quickly, but still sort of takes time to establish a colony and have them, really grow and respond. So again, back to the oxygen conversation, right? Like more oxygen availability, more potential for faster growth for aerobic bacteria. Fungi, still a slightly different mechanism there, but the more root zones, the more root sort of surface area that we have to cover, the more we can create those symbiotic relationships with the mycorrhiza, and they can attach to those root hairs and create that relationship. The problem that we have with this is that, when we're feeding a purely synthetic fertilizer routine, right, a lot of times those bacteria and the plant interactions aren't predicated on the sugars that are being produced to feed the microbes. And so you have to supplement, because you're basically providing direct chelated minerals to the plant root zone. You're just mainlining all of those macronutrients into the plant. The buffer zone for the mycorrhizae and the bacteria, they don't need to work so hard. They're not critical to the operations of that plant with those types of fertilizers, because typically in soil, those plants are breaking down humates and all these things to create nitrogens and phosphorus and potassium and deliver that directly to the root zone. So what we see a lot with people using microbes is what they'll do is they'll do like a synganic is the terminology, or biosynthetic, or whatever you want to call it, where they're using fertilizer, but they're also putting in like fulvic acid and other types of humates and amino acid chelates and other sort of organic enzymes and things that build a biological ecosystem in the root zone that allows those organisms to interact with the roots and the sugar exudates that are coming off the roots in a more effective way to promote growth. But again, it really comes down to oxygen in a lot of cases. So steering the plant, we want to build and establish that colony early on in veg. So on those transitionary phases, like transplanting into your cocoa or transplanting into your substrate, right at that moment, you make your applications and then you continue to feed it. And I think sometimes there's an antagonistic relationship with high salinity environments in the root zone and certain species of microbes that don't operate well. So figuring out which microbes can survive and thrive best in those high salinity environments is really important too, because there's no buffer capacity. Cocoa has more buffering capacity due to the cation exchange in the root zone in the substrate. Rockwool, not so much. So there's less for those microbes and organisms to hold on to, and alkalinity is a little bit lower, so there's not a lot of buffering capacity. So that's something that we still don't fully understand, at least I certainly don't, and a lot of my colleagues we're still understanding how these things are specifically happening in those rhizospheres.
All right. No, those are some of my favorite topics there. We could probably have a whole podcast on rhizophagy and exudates and stuff like that. And for folks that don't know at home, maybe you can briefly explain the role of exudates with plants and, kind of how that's evolved with their relationship with bacteria, kind of like the natural way that it would happen, before we started doing everything that we're doing in CEA.
Yeah, I mean, root zone management is present in every crop and every type of plant and growth, because the plants require nutrition somehow. So in the natural environment, the microorganisms were that sort of conduit to drive nutrients into the root zone of the plant. And so they were taking and breaking down these, rock phosphates and a lot of these like mineral dusts and things that were present in heavy sort of mineral rich soils, and breaking those minerals down in a way that the plant could uptake and absorb them effectively. And so they co-evolved with plants. So you have like nitrogen fixing bacteria and other types of specialists in the root zone that allow, in the rhizosphere, that allow those plants to use and absorb those nutrients, right? So when we're directly injecting chelated and easily absorbable nutrients in the root zone, it sort of bypasses that system. But the reality is a lot of these organisms rely on the exudates of the plant, so the sugars that the plant puts out. So again, back to the photosynthesis equation, light plus CO2 plus water is sugar plus, oxygen, right? So plants are producing sugars as a result of photosynthesis, which feeds the microorganisms in the soil, and therefore they're able to expand and grow, and they take that oxygen and then they pull in those nutrients and break down the soil and deliver that back into the plant tissue.
Yeah. One of my most eye-opening experiences was really getting into that rhizophagy and understanding that the plant's actually attracting the bacteria to the root tips with that sugar-rich exudate, and then the bacteria will actually be sucked into the roots, and the bacterial wall will be dissolved, and all the ions sucked out, and then in some cases, not 100% of the time, that bacteria will be ejected through the root hairs back into the soil to go out and go harvest some more minerals for the plant, essentially. So it's almost like, it's an exchange, right? It's like these little bacteria out there living in the wild, collecting all these minerals and then coming back to the plant to exchange those minerals for sugar. Almost like a form of currency, you're coming back to the city and exchanging your wares, is how I explain it.